attributes or any new unseen data, based on how similar a data point is to an attribute, or in simpler terms, how near it is to the input data point. The algorithm classifies it. Imagine we have two classes in our training set, Class A, represented by red circles, and Class B, shown as blue circles. Let's mark a new unseen data point as a green circle. Now, to classify it, we just expand a specific distance away from our future space until we hit k number of other data points. Here, you can see the differences between various k values. If you are using this method for binary classification, please choose an odd number for k to avoid the case of a tied distance between two classes. In this example, for k equals 3, the green data point picks 3 closest data points, represented by the yellow region. And for k equals 6, the green data point picks 6 closest data points, as shown with the blue region. In this demo, you'll look at how you can use the KNN and logistic regression models to predict the response of any new data. The first thing, of course, is to import the pandas and NumPy libraries. For this demo, let's take up the iris dataset from the built-in scikit-learn datasets. The iris dataset was prepared in 1936 by Ronald Fisher, outlining the structural differences between 3 related species of the iris flower. To instantiate the dataset, create its object. Check the type of dataset using the type method. Python has an inbuilt describe function. You can use it to view the characteristics, statistical summary, additional information, historical background, and references of the iris dataset. The input features of the dataset is already defined. Use this function to view it. Similarly, you can view the predefined target or response of the dataset as shown here. The describe function that you saw earlier provided all the details of the dataset. If you specifically want to know only the shape of the dataset, you can use this function. It shows you that the dataset has 150 observations and 4 attributes. Use the syntax shown on lines 8 and 9 to assign the data to the x-axis and the target to the y-axis. Print the objects x-feature and y-target to view their shapes. Let's first use the KNN classifier method to find the nearest neighbors of the data point for a given value of k. To do this, you must import the kneighbors classifier class from sklearn.neighbors. Then instantiate the class with KNN object. Always remember that the object used to instantiate the class of a learning model is called an estimator. Pass the kneighbor value as 1 so that the estimator will look for the first nearest neighbor. Print the KNN object to view its properties. Fit the data that you have into the model. Recall that we have already assigned the data to the objects x-feature and y-target. Now pass 2 new sets of values to the object xnew for which we'll predict the outcome. To do that, use the predict method on the estimator and pass the value of the new object to it. Now let's try to predict the outcome using the logistic regression model. First, import the logistic regression class from the linear model of Sklearn. Instantiate it using the object or estimator shown here. The next step is to fit the data into the estimator using the X feature and Y target objects created earlier. Use the predict method to predict the outcome for the X new object. Verify the outcome. In this demo, you learned the implementation steps of two learning models, KNN and logistic regression. Clustering is the way to group similar data points. It helps extract the structure of the data and identify its groups. By looking at the diagram, it is very obvious that a greater similarity between the data points results in better clustering. Consider a scenario where you are given a data set where each observed example has a set of features but has no labels or response attached to it. So in the absence of a response, you can identify which data points in our data set are similar. Each similar group of data points is called a cluster. K-means, one of the most popular clustering algorithms, stores K-centroids, which are used to define clusters. A point is considered to be in a particular cluster if it's closer to that cluster's centroid than any other centroid. Now let's see how the K-means algorithm works. You have to first understand the dataset, make some assumptions about it based on your expertise, and then feed those assumptions to the algorithm. Based on those inputs, K-means randomly assigns a specific number of centroids to a dataset. It assigns data points to the centroids depending on their proximity to them. Once the data points are grouped separately, K-means chooses a data point that is in the center of each group. Then it reassigns data points to these new centroids based on their proximity. If this creates a new set of groups, then K-means again chooses a data point from the center of each group to form centroids. It repeats this process again and again until the model is optimized. Let's see how K-means algorithm works in a scikit-learn. Scikit-learn has a class called K-means. It has to be instantiated by creating an object, also called an estimator. Let's take a closer look at the signature of the class. InCluster gives the number of clusters and centroids that are to be formed. init equals K-means ++ selects initial cluster centers. init specifies the number of times the K-means algorithm will be run with different centroid seeds. maxiter specifies the maximum number of iterations of the K-means algorithm for a single run. Precompute distances is used to precompute the algorithm for a faster operation. Random state initializes the centers. If the copy X argument is true, then the algorithm will not modify the data while it carries out the precomputation. InJobs specifies the number of jobs in parallel computation. In this demo, you'll see how we can use K-means clustering to classify data points in a randomly generated sample. First of all, import the NumPy library. Then, import the K-means class from the Sklearn cluster. Along with its built-in datasets, scikit-learn also has random sample generators. They are useful in creating artificial datasets of a specified complexity and size. To load these random sample generators, start typing make and press Tab on your keyboard.